everyone. This is for all the children at home during this COVID-19 pandemic. Join ACE Radio School on Wazobia, Abuja to continue learning while you're at home. This is for nursery, primary, and secondary school children. We will be teaching you literacy, numeracy, STEM subjects. STEM stands for science, technology, engineering, and maths. This is an ACE charity initiative. Powered by the Malala Fund.
This broadcast is for secondary school students. Hello, my name is Adesami Temitayo, and I welcome you to today's English class on ACE Radio School. In our previous lesson, we studied the meaning of a clause and the two main types, which are main and subordinate clause. Kudos to those who sent in their responses to the assignment. You all did very well. Today, I will be teaching the topic types of subordinate clauses. Types of subordinate clauses. Pay attention, students, because at the end of this lesson, I will ask you a few questions. I hope you are all ready. Get your writing materials and listen attentively. What is a subordinate clause? Like you learned in the previous class, a subordinate clause is also known as a dependent clause which does not express a complete thought and cannot stand alone. It needs the main clause to make a complete sense or sentence. There are three main types of subordinate clauses, namely noun clause, relative clause, and adverbial clause. How many? Three. And what are they? Noun clause, relative clause, and adverbial clause. Very good. We'll start with the first one, noun clause. A noun clause is a group of words with a subject and a verb that performs the same grammatical functions as nouns. That is, it can function as a subject of the verb, a subject complement, and the object of the verb in the sentence. I'll take it again. The functions of noun clauses are: it can function as a subject of the verb, subject complement, the object of the verb, and of course, object complement. Listen carefully to the following sentences for examples of noun clauses. A. How Bello passed the examination beats the imagination of his teachers. Underlined is how Bello passed the examination. How Bello passed the examination is a noun clause and it functions as the subject of the verb in the sentence. That is the doer of the action. And what is the verb in the sentence? Beats. Very good. So it is the subject of the verb beats. Sentence B. The good news is that he passed his examination. Underlined is that he passed his examination. Now, that he passed his examination is a noun clause that functions as the subject complement. Subject complement in the sense that it is complementing the subject, the good news. What is the good news? That he passed his examination. So when we have a subject complement, it is telling us about the subject itself, okay? So the noun clause here is functioning as a subject complement. Sentence C, the suspect eventually accepted that he was guilty. That he was guilty is a noun clause and functions as the object of the verb. That's the receiver of the action. Go to the second one quickly, which is relative clause. A relative clause is a group of words that functions as an adjective and contains a subject and a verb. They are introduced in sentences by relative pronouns. And what are these relative pronouns? We have who, which, whose, that, when, where, and whom. A relative clause is also known as an adjectival clause. Its function is to qualify the noun or pronoun that comes before it in a sentence. Listen to the following sentences for example of relative clauses. A. The man whose phone was stolen has reported to the police. Underline this, whose phone was stolen. So the relative clause is whose phone was stolen and it qualifies the noun man. Are you following? Sentence B. The dress which my mom bought for me suits my shape. Underline this what? Which my mom bought for me, and it is a relative clause that qualifies the noun dress. Sentence C. I would like to read a book that is educative. Underline this what? That is educative. Now, that is educative is a relative clause and it qualifies the noun book. Are we following? Very good. Let's go to the third one quickly. Adverbial clause. Adverbial clause. An adverbial clause is a group of words that functions as an adverb and contains a subject and a verb. It performs the grammatical function of modifying the verb in the main clause. It might interest you to know adverbial clauses indicate time, place, condition, manner, reason, and purpose. Listen to the following sentences for examples on adverbial clauses. A. When the sun sets, we will play football. When the sun sets is the adverbial clause and it modifies the verb what? Play. Very good. B. I will build my house where the population is less. Underline this, where the population is less, and of course that is our adverbial clause which modifies the verb build. So where the population is less is our adverbial clause. Now C. As soon as the police arrived, the protesters ran away. Underline this what? As soon as the police arrived, and that is our adverbial clause which what? It modifies the verb ran. Alright students, let's do a recap of what has been learned today. We learned the three types of subordinate clauses, namely, can we name them? Noun clause, relative clause, and adverbial clause. Thank you. Now it's question time. Question 1, are you ready? Remember, you're going to send this question as text message to the number that will be announced. Question 1. What is the function of a relative clause? What is the function of a relative clause? Number 2. What modifies a verb in the main clause? What modifies a verb in the main clause? Send your responses as text message indicating your name, gender, if you're male or female, your state, and subject, that is English, to 070 363 03182. I'll take the number again, 070 363 03182. Alright, well done students for participating with your friends in today's English lesson. Until I come your way again, it's Adesami saying bye for now.
This is an ACE charity initiative, powered by the Malala Fund. Hello everyone, this is for all the children at home during this COVID-19 pandemic. Join ACE Radio School on Wazobia, Abuja to continue learning while you're at home. This is for nursery, primary, and secondary school children. We will be teaching you literacy, numeracy, STEM subjects. STEM stands for science, technology, engineering, and maths. This is an ACE charity initiative, powered by the Malala Fund.
This is for secondary school students. Hello students, my name is Mrs. Oluwashino Teniola and I welcome you to today's mathematics class on ACE Radio School. Today, I will be teaching you indices. I'll also be explaining how to simplify these expressions. Get your pen and notebook and let's get ready to learn. Have you heard of the word index? Yes, index. Index is written as a small number to the right and above the base number. Index is written as a small number to the right and above the base number. For example, 5 raised to power 2 equals 5 times 5. The power 2 is known as the index, which tells the number of times 5 should be multiplied. Another example is b raised to power 3 equals b times b times b. You can see that the tree here tells how many times we should multiply the letter b. However, indices is the plural form of index. Indices have laws. These laws will guide you in simplifying without making mistakes. Firstly, we shall consider the product rule. Take a look at this example. A raised to power 3 times A raised to power 2. Let's start by splitting the a's. A raised to power 3 equals A times A times A. And A raised to power 2 equals A times A. Can we bring them together? Yes. A times A times A times A times A. Let's count the number of A's. 1, 2, 3, 4, and 5. Great. Therefore, A raised to power 3 times A raised to power 2 equals A raised to power 5. Fantastic. Let's try another example. 2b raised to power 3 times 3b raised to power 4. 2b raised to power 3 times 3b raised to power 4. This is quite simple. The first step is to separate the numbers from the letters. 2 times b raised to power 3 times 3 times b raised to power 4. By arranging numbers side by side and the letters side by side, we'll have 2 times 3 times b raised to power 3 times b raised to power 4. Definitely 2 times 3 equals 6. Now let's split the letter b's and count. B raised to power 3 equals b times b times b, while b raised to power 4 equals b times b times b times b. Let's multiply all the letter b's together. B times b times b times b times b times b times b. Shall we count? 1, 2, 3, 4, 5, 6, 7. Fantastic! Therefore, b raised to power 3 times b raised to power 4 equals b raised to power 7. Hence, 2 times 3 times b raised to power 3 times b raised to power 4 equals 6b raised to power 7. Great. Let's consider the division rule. A raised to power 5 divided by a raised to power 2. The first step is to split the entire letter A. A raised to power 5 equals A times A times A times A times A. Good. A raised to power 2 equals A times A. Now let's divide. A times A times A times A times A over A times A. Just like I taught you in fractions. Remember, the numerator is at the top and the denominator is at the bottom. So A times A times A times A times A is the numerator and A times A is the denominator. The first A at the numerator divides the first A at the denominator, which is equals 1. Good. The second A at the numerator divides the second A at the denominator, which gives 1. Beautiful. Is there any other A at the numerator? Yes. A still appears 3 times. But is there any other A at the denominator? No. Therefore, A times A times A at the numerator is what is left. Let's multiply what is left together. A times A times A equals A raised to power 3. Hence, A raised to power 5 divided by A raised to power 2 equals A raised to power 3. Good job. Check out this final example. 6b raised to power 4 divided by 3b raised to power 3. Let's take it step by step. The first step is to separate the numbers from the letters. 6b raised to power 4 equals 6 times b times b times b times b. And 3b raised to power 3 equals 3 times b times b times b. Great! Now let's divide. 6 times b times b times b times b over 3 times b times b times b. 6 times b times b times b times b is the numerator, and 3 times b times b times b is the denominator. 6 divided by 3 equals 2. The first b at the numerator divides the first b at the denominator, which is equals 1. Good. The second b at the numerator divides the second b at the denominator, which gives 1. Beautiful. The third b at the numerator divides the third b at the denominator, which also gives 1. Is there any other b at the numerator? Yes. B still appears one more time. But is there any other b at the denominator? No. Let's multiply what is left at the numerator. 2 times b times 1 times 1 times 1 equals 2b. Therefore, 6b raised to power 4 divided by 3b raised to power 3 equals 2b. Great! I'd like you to try this as an assignment and send in your answers to this phone number 070-3630-3182. Question 1. 4a times 5a. Today, you learned how to multiply and divide indices. Keep practicing, have fun, and stay safe.
Hello everyone, this is for all the children at home during this COVID-19 pandemic. Join ACE Radio School on Wazobia, Abuja to continue learning while you're at home. This is for nursery, primary, and secondary school children. We will be teaching you literacy, numeracy, STEM subjects. STEM stands for science, technology, engineering, and maths. This is an ACE charity initiative.
This section is for secondary school students. Hello students, my name is Ibrahim Mark, your ACE Radio School Physics teacher. Kindly get your pen and notebook ready to take notes. In our last class, we studied scalar and vector quantities. We also learned about distance and displacement. We learned that scalar quantities are physical quantities that have magnitude, that is, they have size, but do not have direction. We listed examples of scalars such as mass, length, speed, and temperature. We further learned that quantities with both magnitude, that is, size, and direction, are referred to as vectors, and that examples of vector quantities are displacement, velocity, force, and acceleration. Today, we shall study scalars and vectors in depth by learning about speed, velocity, and acceleration. Let us start by defining speed and acceleration. Speed is the rate at which distance is covered with time. Speed is the rate at which distance is covered with time. While velocity is the rate of change of displacement with time. Velocity is the rate of change of displacement with time. It is important that you note that when we define speed, we talk about distance and time. But when we define velocity, we define it in terms of displacement, which is distance in a specified direction and time. Therefore, better put, velocity is the rate of change of distance in a specified direction with time. Yes, with time. From this definition, we can clearly observe that speed is a scalar quantity that only measures how fast an object is moving. So speed tells us how fast an object is moving, while velocity, a vector quantity, measures how fast and in what direction an object is moving. Velocity measures how fast and in what direction an object is moving. Next, we shall look at the formula for speed and velocity. The formula for speed is distance divided by time. The formula for speed is distance divided by time, while the formula for velocity is displacement divided by time. Once again, displacement divided by time. Very good. For instance, in the story I told you in our last class about going to the airport, I told you I drove my car at a speed of 60 kilometers per hour. That is how fast my car was moving. Or you could say that for every 60 minutes, my car covered 60 kilometers. With this speed, however, I still arrived at Lokoja rather than the airport. Rather than speed, I should have chosen velocity. To choose velocity, I should not have only asked for the distance of the airport from my house. I should have also asked for its, yes, that's right, its direction. That means velocity, which also has direction, is a vector quantity, and speed, which doesn't include direction, is a scalar quantity. I hope you understand clearly that scalars are quantities that have only a measurement, and therefore speed is a scalar quantity, while velocity, which has both an amount and a direction, is a vector quantity. Lastly, we will look at acceleration. Acceleration is the rate at which velocity is changing with time. Acceleration is the rate at which velocity is changing with time. This means acceleration is derived from velocity and time, correct? The formula for acceleration is velocity divided by time. The formula for acceleration is velocity divided by time. From the definition and formula of acceleration, can you tell me if it is a scalar or vector quantity? Yeah, very good. Very good. Acceleration is a vector quantity. Why? Because it is a change in velocity with time. And we already know that velocity is a vector quantity. You can therefore define acceleration as a change in speed in a defined direction with time. That means when there is a change in the speed, the direction, or both the direction and the speed of an object, acceleration has occurred. To end this section, let us recap what we have learned with an example. If I am running to the market, speed will only measure how fast I am running. The velocity will measure how fast I am running and which direction I am running to. Finally, the acceleration will measure the change in my speed or my direction. If while running I don't change my speed or my direction, then I have not accelerated. Once again, if while running I don't change my speed or my direction, then I have not accelerated. With this, we have come to the end of today's class. Listen carefully to the following questions. They will serve as your assignment. The questions are as follows. Question number 1. The following are examples of vector quantities. Except A. Speed, B. Velocity, C. Displacement. Number 2. The formula for speed is A. Distance divided by time, B. Time divided by distance, C. Displacement divided by time. And lastly, the formula for velocity is A. Distance divided by time, B. Time divided by distance, and C. Displacement divided by time. Send your answers as a text message indicating your name, gender, the state you live in, and subject, that is physics, to 07036303182. I take the number once again, 07036303182. I believe we had fun learning together. Till I come your way again on Ace Radio School, I wish you good speed in your studies in an upward direction. Accelerate.
Hello everyone, this is for all the children at home during this COVID-19 pandemic. Join Ace Radio School on Wazobia, Abuja to continue learning while you're at home. This is for nursery, primary, and secondary school children. We will be teaching you literacy, numeracy, STEM subjects. STEM stands for science, technology, engineering, and maths. This is an Ace charity initiative. Powered by the Malala Fund.